Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning.
Good morning, sir.
So today's topic is, what is the topic? Advanced engineering mathematics.
Yes, advanced, sir. Advanced engineering mathematics er under e amra korchi time series data analysis.
আরেকটা চলছে না আমাদের, আরেকটা প্রোগ্রাম চলছে তো, সে অ্যাপ্লাইড ম্যাথমেটিক্স এর প্রোগ্রাম।
হ্যাঁ ওটাও চলছে, ওটা বিকেলে আছে।
এই এত এগুলো সব ক্লাস টাপ করে একসঙ্গে
খিচুড়ি হয়ে যাচ্ছে স্যার, সবগুলোতে আমরা মানে আমরাও জয়েন করতে পারছি না, ঠিকঠাক হয়ে উঠছে এত তাড়াতাড়ি হলে।
তোমাদের সিলেবাস ঠিক হয়েছে? এবারে আমি কিন্তু সিলেবাস নিয়ে ধরবো, সব সিলেবাস সিবিসিএ সেগুলো সব ঠিক আছে?
না স্যার, সিলেবাসটা তো আমাদের আগে বোর্ড অফ স্টাডিজে ছিল, কিন্তু আবার একটা নতুন করে নিতে হবে, সেটা বলছেন তো?
হ্যাঁ, এগুলো এবারে আগে ধরো, এবারে সিলেবাস গুলো ঠিক করে করো।
Now we can start. Prem?
With the approval of VC sir, you can start now.
লোকজন জয়েন করেছে? কজন জয়েন করেছে?
18 দেখতে পাচ্ছি পার্টিসিপেন্ট।
15?
হ্যাঁ 18। আসলে মর্নিং সেশনে স্যার একটু কম লোকজন হয় আমি দেখেছি, সন্ধ্যেবেলায় হলে লোকজনের জানি না কেন, সকালে কেউ ঘুম থেকে উঠে আর জয়েন করতে চায় না।
হ্যাঁ, আমি তো বলতে পারছিলাম না।
So maybe start now. Mihir, Chunki, all of. Okay. Good morning. It is my honor to welcome all the participants, our Honorable Vice Chancellor Sir, and all dignitaries, and our co-faculty members, organizers, to welcome this 3 days faculty development program. And it is really, we feel happy that it has become a real practice, or maybe a regular aspect, and maybe to impart knowledge and to disseminate the sharing of experience through this webinar from our university platform. So it is really, we are happy at this university to host this kind of faculty development program regularly and a regular basis, and we hope that this will be starting soon. And now I welcome now I request our Honorable Vice Chancellor Sir to say some few words, is inspiring words, so that we can start our FDP program. Sir, please.
Okay, thank you, Dr. Madhumita Das Sarkar. So for the first time probably we are starting these faculty development programs at this early morning, and one of my observation is, instead of 3 days it should have been 5 days, then it should have been a standard faculty development program.
Yes sir.
However, the topic that was chosen for this faculty development programs is a very pertinent one, and this engineering mathematics, and with this idea of engineering mathematics, probably this different models, different these areas of microelectronics, VLSIs, or other areas that will be this discussed, and how these are going to be utilized for different applied engineering sciences. Uh, and that will give very this important knowledge to our all participants, because most of these things now starting from software development, starting from this model development, handling data, and all these things, it requires a solid foundations of mathematics. And here uh, we started another programs in applied mathematics, but more and more programs in mathematics, particularly applied mathematics and engineering mathematics, that are this call of the time. And we need to empower all our these faculty members, all our researchers, all our students with the more concepts and knowledge of this applied and engineering mathematics, so that they can take up all these problems of the problems of model development, problems of handling data, problems of this understanding these complex matters of engineering sciences and all these things in a much better way. And with this, I believe that there will be numbers of participants. Maybe they are taking time to join, but within a short possible time, they will be joining. My sincerest thanks to Dr. Madhumita Das Sarkar, Professor Amitabh Sinha, Dr. Das Gupta for taking these endeavors. And I am very proud that my university, our university, has taken up this initiative in organizing a series of these training programs, faculty development programs for the benefit of the learning communities. And one of the biggest advantage is that of this digital platform is that at any point of time, these types of programs that can be organized, be it early morning, be it late evening. And that's the beauty of the things is there is the probably the perhaps this best this opportunity at this scenario where we are uh, taking this the much of the benefits of these digital platforms. And with this I would like to conclude, because this is the time for real session to start. My thanks to all the resource persons. They have consented to be present over here at this time, and for the benefits of our learning community. And I wish this program a grand success. I wish that all the participants will be immensely benefited out of it. And I would now like to request Dr. Madhumita Das Sarkar to take this program further. And my sincerest thanks to again to all the members of the organizing committee. Thank you all.
Thank you, sir. Thank you for your inspiring words for our FDP and for also for our department, so that we can really carry forward this kind of FDP uh, uh, in this session and as well as for the further future session. Thank you, sir. Thank you once again. Now I am taking the responsibility of communicating Mr. Shoboshachi Sen of our department to host the thing, so that the next session can be, the next proceedings will be the keynote, and the other addressing sessions, inaugural sessions can be now. Now it is over, and now we are starting our keynote speeches. So please, Shoboshachi, you take that.
Right. So, letting everyone, our Honorable Vice Chancellor and every dignitaries and senior faculties, my respect to everyone, and my greetings to everyone. I am going to start the webinar today. So the first thing is that we have at first there will be a inaugural session, inaugural ceremony. So inauguration already our respected Honorable Vice Chancellor sir has already inaugurated the session. So next keynote speaker or inaugural speaker is the Honorable Vice Chancellor of IUST Jammu and Kashmir. So is he there?
Actually, I think he is not with us. And Dr. Giri is not with us in this at this early morning. Maybe we'll be having him uh, after some time. Maybe now we can forward this, Shoboshachi. You
Right,
can start with Professor Sinha for it.
right. So I will request Professor Sinha to have some keynote words for this webinar session. So if you kindly have some words for us, inaugural words.
Actually, SAD will be giving some keynote speech, keynote about this faculty development program. SAD, if you please uh, start with that, it will be very much like enlightened for the participants as well as for the
Invite
other.
Dr. Dasgupta to say something. Then.
Yes, Professor Dasgupta. Rather, I will request Professor Dasgupta sir to have some words for us in this inaugural session of this webinar, first day webinar.
No,
So
okay, Professor Sinha, since you have started with Professor Sinha, let him say, I mean,
right,
his,
right,
I think,
right.
deliver his speech. After that, I will definitely speak.
Okay, okay. Sir, please.
Okay. So, am I audible first?
Yeah, sir. It's okay.
So, Honorable Vice Chancellor, respected panelists, dignitaries, and auspicious audience. It's my privilege to get an opportunity to say a few words on time series analysis with my little knowledge and experience. In fact, time series analysis with the electrical engineers we see from time domain analysis, and it's an old field, in fact. But in recent times, the need of study, understand, and analysis of the evolving content, structure, and usage of interlinked data has gained tremendous importance and attention to the researchers, especially with the advent of technology synergy between computer technology and communication engineering. Our Honorable Vice Chancellor very rightly pointed out at the beginning that the foundation for any subject is very, very important. In fact, here also the same thing, the time series analysis, this is not a new field, but in recent times, it has gained the attention. In fact, what we have witnessed, the emergence of World Wide Web, which has made it simpler to analyze online data. The analysis of experimental data that have been observed at different points in time leads to new and unique problems in statistical modeling and interference. In fact, the obvious correlations introduced by the sampling of adjacent points in time can severely restrict the applicability of many conventional statistical methods that traditionally depend on the assumptions that these adjacent observations are independent and identically distributed. The methodical or systematic approach to address the mathematical and statistical questions posed by these time correlations is commonly referred to as time series analysis. In fact, time series analysis for the case of electrical, electronics, mechanical engineers, they have been doing it for a long time now. And basically it was analysis with the data at different times, recording the data and to get information from the data. That is the need of the hour. In fact, the motivation to study time series model is twofold. First one is to obtain an understanding of the underlying forces and structures that produced the observed data. And second one is fit a model and proceed to forecasting, monitoring, or even feedback and feed-forward control. In fact, traditionally, the time series methods were applied to problems in the physical sciences, environmental sciences, and in engineering sciences. In fact, due to this, the basic engineering approach dictates the languages of time series analysis. In our approach, in fact, the first step in any time series investigation always involves observation of collected data plotted with respect to time. That means x-axis is t and y-axis is a function of time. So more precisely, it can be said that plotting a graph of ft versus t. So before looking more closely at the particular mathematical or statistical models, it is appropriate to mention that the two separate but not necessarily mutually exclusive approaches to time series analysis exist, commonly identified as the time domain approach and the frequency domain approach. We'll discuss the frequency domain approach later on. First, let's see what is a time domain approach. The time domain concept can be defined as collection of series of values or magnitudes over a period of time belonging to different time periods of some variables of composite of variables, such as the production of steel, per capita income, gross national income, price of sugar, index of industrial productions. And in the engineering field, we can, for speech signal, we can think the amplitude of the signal at a particular time, or for biological, medical sciences, we can think of ECG signals at a particular time, okay, or image signal at a particular instant. So, in fact, in reality, we deal with this time series, knowingly or unknowingly, but analysis, depending on the application, that is the need of the hour. So time is act as a device to set of common stable reference point. In time series, time act as an independent variable to estimate dependent variables. Now, to understand the time series analysis techniques, first we must understand time series can be defined as an ordered sequence of values of a variable at equally spaced time intervals. The motivation to study time series is of twofold. Now, before that, when we talk about equally spaced, even for some engineering applications, when we deal with the time series signals, then we sample at regular interval. And this sampling is governed by the theorem, which is known as Nyquist sampling theorem. So mathematically, in fact, if we analyze, if we think that a function has infinite number of frequencies, then in fact, it needs to be band limited so that a maximum frequency exists. And based on that, the sampling theorem, Nyquist sampling theorem is applied to that. Anyway, so to obtain an understanding the underlying forces and structure that produce the observed data and feed the model and process to forecasting model, even feedback and feed forward control. That we have just, in fact, time series analysis can be divided into two main categories, depending on the type of the model that can be fitted. One is the kinetic model, another is the dynamic model. In fact, in the kinetic model, the data here is fitted x equal to ft, function of time, and the measurement observations are seen as a function of time. That means at a particular instant, what is the value? And in the dynamic model, the data is fitted as a number of discrete data at different times. The classical time series analysis procedures decomposes the time series functions into four components. They are trend, the trade cycle, the seasonal component, the residual component. I'm not going in details of this because I believe that our honorable speakers will be discussing all that. But smoothing methods, in fact, are some existing methods which are there. So one is the most important, that's the smoothing methods. In fact, when you collect data over time, there exists some form of random variation, which is inherent in the collection. Now, these random variations, in fact, from that, some kind of noise will be there, and that needs to be removed. So, to reduce the effect, if not totally cancelled due to random variation, a popular technique often is used, which is called smoothing. And in fact, this smoothing This technique is also used for imaging applications, for video processing, for image processing also. There are two distinct groups of smoothing. One is the averaging methods, what we call typically moving average filter. Okay, is basically average of this. And another method is exponential smoothing methods. This is a very popular scheme to produce a smooth time series, whereas in single moving average, the past observations are weighted equally. So in fact, this method is based on the present and past both. In the language of signal processing, we call it a recursive model. Then time series models and forecastings. Time series models can be divided into two parts: univariable model, and in fact, the most important things are trained seasonal residual decompositions. Now, so an auto-regressive model is amply a linear regressions of the current value of the series against one or more prior values of the series. The value, in fact, a particular value is called the order of AR model. Now, moving average model, MA, this model, already I have talked about it, so not going into the details of this, but this is a very popular model. Now, forecasting models. Now, forecasting method is basically the predictions. The main objective of forecasting of a given series is to estimate the future values from the present and the past values. And here also, the applications will be in the image compressions, where the next image will be predicted. For an example, in fact, when a video is recorded in a room or in any place, then what happens? In between two successive image frames, the difference is very small. So this difference, in fact, instead of sending the whole image, whole frame, only the difference, if it is sent, in fact, then the bandwidth requirement will be less. And in fact, cost will also be less. Time will also be less to transmit the data. In fact, further improvement has been done on the predictions. So based on the previous images or previous frames, if the frame is to be predicted, then based on the predictions, there could be some error, and only the error can be transmitted. In that way, in fact, less data will be transmitted, but in fact, from that, the entire image can be formed. So these predictions method is very important methods of time series analysis. So in fact, time series analysis has been broadly adopted to scientific research and engineering applications. Many theoretical developments and new methods for time series analysis have significantly contributed to the understanding of complex systems. However, when system complexity increases, it becomes difficult to describe the dynamic behavior from time series, and traditional time series analysis methods have difficulties coping with the specific burdens of this increased complexity. There are still many challenges in the development of time series analysis methods addressing such problems. So advanced techniques of the time series analysis provide new avenue for analyzing complex systems and will result in acquiring substantial knowledge in a broad variety of fields of science and engineering. Some of the emerging and important research areas are application of AR model in the analysis of earthquake, adaptive filter for cognitive radio, spatial information entropy and its applications in the degradation state identification of hydraulic pump, human activity recognition as time series analysis, applying data mining techniques to identify suitable activities, then intrusionistic fuzzy time series forecasting model, and prediction algorithm for image recognition, just as I told just now. Now, here are some of the applications briefly we can discuss, like training deep neural network with reinforcement learning of time series forecasting. It's a very good application of time series, in fact. As a kind of efficient nonlinear function approximatives, artificial neural network, because their functions are basically nonlinear, have been popularly adopted to time series forecasting. The training method for artificial neural network utilizes error backpropagation, which is a supervised algorithm. Time series analysis tool is very popular in business forecasting also. The basis for understanding past behavior, can forecast future activities planning or future operations, evaluate current accomplishments, evaluation of performance, facilities comparisons, estimation of trade cycle, examples of stock price, exchange rate, interest rate, inflation rate, national GDP, retail sales, electric power consumptions, number of accident facilities, etc. Prediction in image compressions, Kalman filtering for noise removal from image speech or from any time domain functions. Now, however, in time domain, we can't see some hidden information which can be made available in frequency domain. Basically, our interest in this time series analysis is to extract information, more and more informations. Okay, and from that we can come to some conclusions, okay? And we can investigate something. But truly speaking, there are many hidden information which cannot be obtained from time domain. That's why we use the frequency domain approach. So this frequency domain basically converts the time domain function to a frequency domain. So here, what we see in the time domain functions, at a given instant of time, we get the value. Whereas in the frequency domain, we get the amplitude of a particular frequency. So here, x-axis is the frequency and y-axis is the amplitude. So here, the frequency information, which is not available directly in the time domain, that is here. But frequency domain approach also has some limitations. Traditionally, we use the Fourier transforms methods for extracting the frequencies, but it has limitations in the sense. For stationary wave, it functions well, short-term Fourier analysis. But for non-stationary signals, it is not okay. In fact, it doesn't give the entire information. For an example, let's say a function for some period, it has some sine wave of a particular frequency. After some time, it gives some different frequencies. So here it can't give the information at what time that frequency occurred. And for that, in fact, wavelet transform has become very popular recent times. So this, in fact, this led to the invention of new theories and applications of the time series analysis. Analyzing dynamical systems in a time-dependent complex system from observed time series or just one or at most a few variables is a fundamental problem of significant importance in many research fields. So to conclude, I would like to mention that even though by time series we are able to analyze and investigate a wide range of applications in different scientific, engineering, environmental, and business domain, we have to keep our eyes open to invent newer theories, possibly derived from the series, but for better understanding and analyzing the problems. Thank you very much.
Thank you, sir. Thank you for your very knowledgeable speech to us. Next, I would request our Honorable Director, sir, Professor Dasgupta, sir, to have some speech, to have some inaugural or keynote speech in this session of the webinar. Hello.
Hello.
Ah,
Hello.
Yes,
director sir is there.
sir. Director sir, I think has some network connectivity problem. He will be joining soon. So you can proceed, sir.
Okay. Uh, Next, I would request our honorable TechIP coordinator, Dr. Giri, to have some few words
Sir,
in this
Giri sir was
inaugural
also not
session
able to
of this
join.
webinar.
Sir, Giri sir was also not able to join. Sir.
Giri sir was not there, or he is not there, right? So next, I would request our honorable head of the department, Dr. Das Sarkar ma'am, to have some speech, inaugural keynote speech in this inaugural session of this webinar. Ma'am, please.
Hello. Yes. I'm coming.
Yes. Hello.
Yes, ma'am. Please continue, ma'am. Madhumita, ma'am.
Yes. Uh, Somehow the video is not coming. I think some problem is there.
No video. We can see
Yes, it is visible, ma'am. Please continue, ma'am.
it's coming. Please
It is
continue.
coming. Okay.
Yeah.
So what actually this faculty development program for the analysis, time series data analysis, or better to say that quality control of time series data is really pertinent to this context, especially when we are in the data-driven field. Because we know that yes, the system or any instrument, measuring instrument, or any system or any observable quantity, actually when we are observing that it gives some measurable or observation data we are collecting from any instrument or any system with a variation of time. So that means it gives some series of data. And said Professor Sina, our respected teacher, he has also pointed out that yes, it is very important, and it was there in physical systems and in engineering science and electronics and electrical to analyze the data in the time domain signal. So actually, when we are in the digital domain, we are getting the data at a particular time. So when we are collecting a huge number of data with the changing of time, so we are actually having a discrete kind of data. It is not, we are not knowing about the system, physical process that is happening behind this system. So actually we are getting the data, but that data, how they are behaving, we don't know. So in this situation, when huge number of data maybe from out of a system or instrument or any physical process, or even it may be in any kind of biological system, or any even in COVID academic also, COVID pending pandemic also, we are seeing that with time there is a variation of this process, or even the pandemic process is changing with time. So in that case, if we collect all those data from that particular time, a series of data we are collecting, and it is the time series data. Now behind everything, this process or system or measurement, there is a physical process. But the analysis, though the scientist or maybe the businessman or economist, those who are taking that time series data, they don't know what are the physical process actually involved in this time series data. So what to do by seeing the trend or the distribution of the data, how it is varying. So from this, they're trying to develop a model. That model means through this data, whether we can earlier of what we are telling that it is the kind of estimation, whether the linear plot or maybe the logical any kind of reasoning, or maybe kind of curvilinear approximation, maybe spline, maybe Lagrangian interpolation, that kind of things here earlier we are doing. So in that case, what we are getting, but here as the systems are dynamic maybe, and not, and it always contains some kind of uncertainty because it is the physical system. So there will be no accurate and ideal laws maybe the data is actually giving us So in that case, how do we process that data to develop a data-driven model so that the underlying physical process that is actually happening behind this data, we can we can develop that model and can find out or extract the phenomena, and even from that data we can even find which are the parameters, which are the sensitive parameters which are affecting the output, the outcome. So in that case, really the development of data driven model is very important. So finding the trend and the distribution, how they are varying, where their mean or peak positions, is it a normal distribution or not, by inspecting or by investigating all those, we can develop the data driven model. So the data where we cannot reach, we cannot find the exact principle, but we can observe some data, we can collect some data, then we can develop this kind of model. And as we are in the digital domain, in the digital world, everything is like the data is coming, information is coming. So in that case, that out of that data, what are the underlying information we have to find out. And by we think that this in this sense, the time series data analysis and the other sessions will be very fruitful for capturing this kind of information. And as Sarah has pointed out, that every physical system are there some the inherent noise. So we have to remove this noise. So we have to know that how this noise can be eliminated to get the actual data. And ultimately, how can we develop the data-driven model so that the behind principles or behind physical principles or the theory we can estimate, and the parameters which are sensitive parameters that can also be extracted out of this data-driven model. So in this FDP, the faculty development program, we are trying to make the session in such a way so that from the simple data or the simple time series data, how can we develop a simple model, or maybe the better to say the statistical model, and the basic things after finding. And if there is any kind of missing data, outliers that are called outliers, that missing data, how can we know that data are missing, and how can we overcome these missing points, one thing. And sometimes it is happened that the missing data which are actually not missing, they may be are some kind of experiences, that means some kind of happenings that occur in between these two data, so that are called the experiences. So in that case, whether the missing data we can remove or the missing data we can take it as experience, that kind of things during the development of data driven model is very essential in this context when we are in industry 4.0. So hope these sessions, all the faculty development sessions, will be helpful for finding this kind of problems and how to develop ourselves to accommodate all the data so that we can really be involved and we can proceed with the industry 4.0 parameters like monitoring, automation, and intelligent system. Thank you. And I think now our respected director, sir, director of engineering and science, will be telling some few words so that the session will be started with a very high spirit.
Right.
Sir,
Right.
yes.
Ma'am, I think Dasgupta sir is not able to join due to some connectivity problem. You can call Sibme sir if it is possible.
Hello.
Yes, Sabyasachi, since Dasgupta sir is not present right now, I think
Hmm.
he has some internet connectivity problem. You may call
So can I go to the next session? I mean,
No, no,
next
no.
session I'll
You
talk.
just
please
one thing. We
one
can
minute
call.
wait.
Right.
We can see that the study has. What is the
Right.
problem behind? We wait for some time for Professor Dashgupta.
Please call him, I think. Call Pausha Dasgupta.
Sir, I am calling. Hello, sir. Sir, connectivity হচ্ছে না নাকি মানে we are waiting, sir. হ্যাঁ স্যার স্যার আপনি জয়েন করুন, আপনি স্যার জয়েন করুন, আমরা ওয়েট করছি। না 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 স্যার, স্যার আচ্ছা স্যার, হ্যাঁ স্যার আপনি, হ্যাঁ স্যার আপনি আসলে আমরা, হ্যাঁ স্যার আপনি আসলেই আমরা একটু একটু আপনার কথা শুনতে চাই। হ্যাঁ হ্যাঁ ওকে ওকে স্যার। Yes, sir has some internet problems, so we can start with our respected delegates and respected speakers.
Right.
Dr. Dotto, Professor Dotto, Professor Devobroto Dotto, he is with us. So Shobhashati, please tell something about him so
Right.
that sir can start.
We are very much honored to get such an eminent scientist like Professor Devobroto Dotto from the BARC besides us to make this webinar a grand success. He is a basically retired scientist and former head of the radiological physics, former head of the Department of Radiological Physics and Advisory Divisions of BARC, Mumbai. He is presently associated with SRM Institute of Science and Technology as an adjunct professor and as a visiting professor in the Department of Mechanical Engineering of GLA University, Mathura. He is also the professor of Homi Bhabha National Institute. His research interests are very vast field. He generally works on algorithm development, software development, basically related to nuclear science and technology domain, uncertainty analysis and radiological risk analysis, problem solving using soft computing techniques, machine learning using imprecise data, fuzzy finite difference method, etc. He has published near about 110 articles in peer-reviewed journals of reputed publications, along with 30 book chapters, and has an H index of 14 with 691 citation. He has been honored with several prestigious national awards like eminent scientists, along with meritorious awards from National Society of Radiation Physics and Association of Medical Physicists of India as well. So I am conveying my humble respect to Professor Devobroto Dotto I am requesting him to deliver the sessional talk for this session, first half session of the of today's webinar.
One thing, sir, if Professor Sengupta comes and he is able to join, sir, please, we would like to have some talk from him. So in that case, Prabhoshati, you please help sir to deliver something. If Professor Sengupta comes, okay?
Right.
Professor Dasgupta, sorry. Sir, please,
Sir, please.
Professor Doctor, you are
Yeah,
here.
yeah, I'm here. So can I
It is
start
not,
now?
sir. You please
Please start.
I
the
have
video,
muted.
sir.
Yeah,
Please,
yeah,
sir, your video
yeah,
you can
yeah.
share.
Can I start now?
Yes,
Yes,
Okay.
sir.
sir.
Yes, please. Yes.
Okay. Before proceeding towards the actual session, I heard about the Honorable Vice Chancellor speech as well as Professor Amitabh Sinha's speech, and I think that the Amitabh Sinha sir has already made my talk slightly easy, though I will cover the whatever he has discussed in this talk. So before starting, as a formal procedure for any FDP, at the outset, I would like to thank the organizing team for organizing such an event in the pandemic situation, because we are all in the virtually connected. So that itself is giving the useful technology of the digital platform and the time domain. One thing that when I started my career in BRC, I only wanted to know that uh, as the time passes, how we change ourselves. You have seen that earlier we were not that much of uh, doing the cleaning of our materials, but now we have learned cleaning, and that is because of the another force, which is a partner force called as a COVID-19 pandemic. So therefore, this gives us a signal that time arrow, which is a very, very fundamental concept and very deeper meaning. Time arrow. Time always moves forward. It never looks back the backward. So therefore, forward marching, how it moves and why it moves is a very, very important for time series analysis. And time arrow, if you look at, Ilya Prigozhin, who has developed the irreversible thermodynamics, and time arrow developed from that, and then finally he gave along with the Onsegar, which is a reciprocal relation which gives the material flow, and that is why we are in a position to develop the composite materials for today's technology. So everywhere, time is an important part. There are many models are available. We worked in the nuclear domain as a resilient model, dynamic model. There are many filters called as a polynomial chaos filter. Of course, Kalman filter he has mentioned, but apart from the Kalman filter, we have a particle filter, which we have developed. And as you know that throughout our country, we have a several nuclear power stations which produce the electricity. And in the control room, if we sit, we know that what are the time domain signals are coming and how do we control our reactor to produce the electricity under the safe conditions of the environment as well as the safe condition to the human. So therefore, with respect to that, as it is a faculty development program under the banner of Advanced Engineering Mathematics. So therefore, mathematics plays a very important role, but to ornament mathematics, we need that there is some customer. So this here, the customers are nothing but the data or other information. So let us try to explain this particular event, how the data looks like, and what are the things generally one should be equipped for time series analysis. So I will share my presentation. You just tell me that is it visible or is it not visible. Okay, let me share my screen and then you can just put this one. Okay,
Yes, sir. Yes, sir.
yeah. So is it visible now?
No.
It is coming, sir. Started
It
sharing.
started screen
Yeah,
share. Yeah,
yeah.
Yes,
now it is.
started.
Now it,
Okay, okay, it is coming, na? So
yes, sir.
now I
Yes.
can just proceed from this here slideshow so that you can. Now you see that my first topic I will keep under the advanced engineering mathematics banner. It is nothing but the multivariate time series data analysis. Many people may object that time series data analysis is always an univariate. But I always call it a multivariate time series data analysis. Why? Reason is that the time domain is not the uniform. 8 to 10, whatever it has happened, that may not be the similar for 11 to 12. So every time domain, we have some different types of event taking place. If you look at the ECG signal, EEG signal, and not only that, I have developed a very useful information that is called conjointed brain. Conjointed brain means when more people are in the control room, how the decision can be taken to get a particular solution so that electricity can be produced and turbine can be operated very smoothly. So apart from this, my applications of the nuclear domain and all these things, we require the multi-scale multi-physics problem. So when you go for the multi-scale multi-physics problem, that multi-scale is connected to the multi-time, because scale is connected to the frequency and frequency connected to the time. So therefore multi-scale I understand is a multi-time. So that means variations of time occurs, and therefore I call the multivariate time series data analysis. Okay. Now, the first day, what are the learning objectives? So we have to see that the nature of data and corresponding statistics, that is related statistics. Then we have to know that how the sample size estimation, because there are many bookish theorems are there. But in practice, you know that the authors have written something for everybody, but for a particular application, that thing never works, because whatever the uh, speech I will give, it is from my own experience in the nuclear field, and where we have developed the product and we have designed. And as you know that throughout our country, so many power stations are there. We have uranium mining and milling. So many other plants are there. So where we work there. And not only that, I was the coordinating, or I was the in charge of many of the defense materials where the missiles were working. And not only that, throughout the country, whatever the radiological hospitals are there, all the hospitals were under me. Even in the Calcutta domain, that the gun cell factory, all the other defense like Shipping Corporation of India, Garden Ridge, everything was under me. So I know that where the time series signal, and even if for a simple welding, how that the welding takes place, that everybody I have seen, I have guided many people. From that only, sample size estimation is very, very important. So then we require a maximum likelihood method, which is a very important. I will explain one by one. Then we'll go for the actual fundamentals of time series and its component. Here I will mostly describe about what is time series. Many people may be knowing from the book or from the many literature, but I will explain from my experience how a scientific organizations looks that a time series component, which I call the resilient model and the dynamic model. Then describe what forecasting is. Of course, very simple. As Professor Sina mentioned, that the smoothing a data series, like moving average, exponential smoothing. There are many kinds of smoothing takes place. Then forecasting using some kind of trend models, which trend model I will not discuss here. Some other session, I think tomorrow I will detail about that, but I will touch upon just surface that what are the things we are going to do. Here you see that the simple linear regression, autoregressive. Then I will come back to a new component that is called Hart's exponent, which is basically nowadays used for any kind of time series analysis for finding that the air quality index, water quality index, many kind of index determinations can be done by Hart's exponent, which will bring you the fractals, and then fractal will take you to the domain called the long short-term memory. So therefore, these are going to the machine learning, which will ultimately give a product like a robots, or we can work on the robotics, because robot always works under the time domain. So now let us see that how the data can be classified. Okay, when you took the data, it can be a qualitative, it can be a quantitative. So if you look at the qualitative data, it is a normal and ordinary variables that has to be done by non-parametric test. Hardly any literature you will find it out, the time domain non-parametric test. So this is a research scope where really we have to carry out how the non-parametric test can be carried out in the domain of the time. If you look at the quantitative, of course, we have an interval and ratio variables, and there are a lot of many parametric tests are there. And one more thing I would like to mention, the data can be continuous, data can be discrete, data can be corrupted, which nobody has mentioned that why what type of data can be called as a corrupted. Corrupted data is simply that you are asking to collect the blood sample of a dog, right? Now what you'll do in your nearby area, you have never seen a dog which you can suck the blood from that. So, but you have to produce, what you will do instead of blood from the dog, you will produce some other animal's blood and give it the sample. So then the data is corrupted or cooked. You have not produced actual the data. So therefore, such kind of data is also called corrupted. And not only that, when you purchase the milk, if the milk is adulterated with some water or some other thing, that is also corrupted. So therefore, with the corrupted data, how much of corruption is there, that if we can find it out, that is called the actual time series analysis. And I understand that the corruption is everywhere, so time series analysis can bring the power to delineate the corruption. So that is the most important part. Forget about the scientific organization. It has got the huge application to the social domain. So all the social networks are corrupted. All the political people are corrupted. So that much of corruption, how do I do? That can be done by that. So that can be applied. So therefore, the time series analysis can also bring a wider platform with the corrupted data. Is a very important domain. So data all around, you see that the lots of data is being collected and warehoused, and there is a web data, e-commerce, financial transactions, bank credit, online trading, so many, and social network, as I mentioned. So the data is everywhere, and so many places so many resources from where the data can come. If you look at this particular slide, it is a temporal scale. It is a time series in crystal growth. If I try to do the laboratory analysis, a crystal, how it is growing, it is a multi-scale, multi-physics problem. So it is nothing but the fracture toughness, all these things can be done by knowing that the time event sequences in the crystal. So therefore, time series analysis, if we do, you can also find it out, the property of the crystal. And when you specially try to do the composite materials like fiber optics, or like the simple, our Cambys tennis ball, these are composite materials. Then let us see that the example. This example I always explain because this gives a lot of thoughts into that. If you look at when you collect a large amount of data, we call it the population, right? But we do not know what is the size of the population. That is totally hidden for us. So to test the population, we try to collect a sample of the data. So therefore, I have shown here that this is my sample and this is the population. Okay, now if you look at this figure, every time if you collect a sample, say more than 30, then you will have a Gaussian distribution. But if I look at from the left-hand side, so this is a simple sample for 1, this is a sample for 2 of the same, and this is a sample for 5. So you see that the time domain wise, if I try to collect the more and more sample in a less than 30, so the distribution is different. So my question is that if I give you this data, how do I know this data has come from this sample, this sample, this sample, or this sample? So this is the challenging for the time domain working, which we call in the hidden Markov model. I will not show you here, but last day I think I can explain that what is the hidden Markov model, which is a very, very important, because people always work, measurement people always work in the one domain, Gaussian. But in practice, if I look at a chirp signal, it is not the Gaussian. So we have to go for the Markovian technique. So Markovian technique is one of the very, very challenging process. So this particular slide is very important, that you know this sample. Okay, you know this distribution. How do I know that this distribution has come from which sample? That is only the challenging. So therefore, to do that, we may do some kind of bias, we may have some precision, we may have some accuracy. So these are the parameters for data analysis one should always be equipped. So what is bias? As usual, it is an error, true value minus observed value. But since you do not know that the true value, we never know what is true. So always we try to go for the best estimation, right? So this best estimation is one of the very, very important domain. And I have hardly seen in the international forum that even in the France, USA, so lot of people, they try to develop the best estimate, because true value we do not know. So that means bias modeling is very, very important. Then what is precision? Precision, if you ask it is defined as a standard error of the estimate. That means sigma, that is the data sample standard deviation, divided by square root of sample size. So that way you can have a precision. Then what is accuracy? Accuracy can be defined as a precision plus bias. Now if you look at, if I unbiased estimate, that means bias is not there. So whatever my accuracy, we can say that I am precise. So always we say, you may be precise, but you are not accurate. You may be accurate, but you are not precise. So that is why the precision and accuracy, they are mutually not exclusive. Okay, you can always say I am accurate. Then I will ask the question, how do you precise? What is your precision? You may not be answered. If I say that, if you say me that, sir, I have precisely got this answer, then I will say how accurate you are. You will not be able to. So all these things is very, very important. So therefore, we try to bring some other things called sensitivity, which measures the proportion of actual positives that correctly identified as such. Then we define a specificity, which is also called the true negative rate, because these are all parameters to be equipped for any kind of data analysis, that sensitivity, specificity. If you look at the mathematical formulation, so this is the true positive rate is defined by this: true positive divided by true positive plus false negative. True negative rate will be defined by this mathematically: true negative divided by true negative plus false positive. Then positive predicted value can be defined as the simple operation true positive plus false. Because because of this kind of thing is not properly defined in our West Bengal COVID-19 pandemic, we are not able to reach the peak at all. Not only that, our state, many other states in the country that of India, whereas Sweden and then Italy, France, they have already availed their peak because of this kind of definition they have given. They have identified during their test what is true positive rate and true negative rate. So this time domain is very, very important, because in that case their entropy positively increases. If you try to look at the entropy in our domain, Bengal domain, basically you will say there is no definition for, there is no quantification for entropy at all. And nobody has quantified. I will show you some of the examples which I worked with at the COVID-19 pandemic with the WHO recently and CDC. So therefore, false discovery rate is given by this and false omission rate is given by this. So these are the parameters one should take care to quantify. So therefore, apart from that, we also try to formulate a confusion matrix, which is a very, very important. And confusion matrix is a platform where you will be having some kind of interaction. It is a 2x2 contingency table where I am showing you that the true positive and true negative and false positive, which is a type 1 error, and false negative, which is a type 2 error. So we should quantify what is a type 1 error, what is type 2 error. So time permits, I will explain. If not today, maybe tomorrow. So now, so these are the first prelim consideration of the data. Second part of the data is why that the data is distributed. If I ask you simple questions to the students, many times we interview people and then they reject because I just plot a graph, exponentially. Then I asking that why this data exponential? Can you explain? He will simply produce a simple equation n equal to n0 raised to minus lambda t. But methodologically, from the data, why it is exponential, if I ask you, he will not be in a position. Because this particular concept comes from the software engineering domain. I will show some of the examples that how we can prove that our COVID-19 data is an exponential. Why it changes. If I plot, it is showing. But is it an exponential? No, it is not an exponential at all. So all the messages, whatever you have heard in the television, media, all are wrong, 100% wrong. So therefore, we need to identify what is the density function for any kind of probability density distribution. So this is an uniform distribution. This is a CDF. And then for every probability density function and cumulative distribution function, we require certain property, which is in general called as the moments. Okay, so we have a median, we have the variance. If it is a moment about the mean, 0 if I say, and this is the standard variance we can say. So therefore, the for an uniform distribution having this density function, cumulative you can integrate and then you get this. And if you look at this mathematical expression, you can always quantify for an uniform distributions having this parameter A and B, what should be the variance of that. So uniform distribution within the 0, 1 is the distribution of the random number that has a mean of 0.5 and variance of 1 by 12, and the CDF is 12. Okay, fine. So the data can be also exponential distributed. This is an exponential distribution function. This is the cumulative distribution function, and if we plot the various property, I get the property. So these are the very standard available in any book. Okay. Now, if you have a hypothesis testing procedure, so these are decision rule. H0 is the hypothesis accept. This is the hypothesis reject. As I shown in the confusion matrix also, this is the correct decision probability. Whatever the analysis we do, I have to take some decision whether my analysis is correct or not. So how do I take the decision? This particular table should be adopted to find it out. What is my power of test? That is beta, and what is my type 1 error? That is a significance level concept. Now, as you know that these things can be very quickly mentioned that if your degree of freedom is the number of data is n minus 1, and the level of significance may be the probability of rejecting the hypothesis when it is true. This is as usual standard statistics. Then we apply the so therefore many of the time, as you know, we may not be just 1 minute. I just hello. হ্যাঁ করিয়ে নাও, টেস্টিং তো অন্য কোনো হসপিটাল থেকে করাবে। হ্যাঁ করিয়ে নাও, কোনো অসুবিধা নেই, একটা রিপোর্ট তো পাওয়া যাবে। ঠিক আছে ঠিক আছে ঠিক আছে ঠিক আছে ঠিক আছে। হ্যাঁ, so sorry to interrupt. So now what we are stating that when you go for the previous domain, you see these are the all the thing we have given. Now our idea is that we never have any normal distribution, because my sample size, if I know that the more than 30 for any kind of field situation, sample size will be normally distributed. Since we are not in a position to collect those samples, so therefore we always go the normal like distribution, which is a student-t distribution, and the student-t distribution basically we apply for estimation of this sample. What should be my sample size? You can easily see from the field experience. I have the questions here. How many samples we need to ensure that the measurement mean was within the 2 milligram per meter cube within a confidence level of 95%. If you look at, see, I have started this problem. This is the developed by myself only, and it has been published long back in many of the journal, and a lot of citation occurred. So it is a sample standard deviation. We have taken the 3 because we had given the problem as a 3, and the difference between sample mean from population, this was the designer's choice, it was the 2 as per this specification. Confidence level, it was 95, and alpha, depending on that, we will get the 5% level of significance. Okay. Degree of freedom is a total number of observation. I took purposefully my 31 samples so that my degree of freedom will be 30. So T statistics give me the sample size formulated by this. So therefore what we do, I will look at the table value of the T with the 30 degree of freedom, 5% level of significance, I got 2.042. Substitute this value of T here, and knowing all other parameters S and D, which I've shown here, you will get that the sample size is 9. So does whether we have to stop it here? No, we have to repeat the same thing. Since my degree of freedom now sample size 9, so my degree of freedom is 8. I'm keeping my level of significance same. I got the value from the table, then repeat the process. I got the 12. This way, if I repeat, you will see that at a certain point you have a convergence. So this is your sample size with respect to this particular problem. And that is why when I published, it opened the eye to many statisticians that very simple way a sample size can be estimated. Same kind of sample size can be done in the time domain also. Now coming back to the next stage is the time series analysis, is the maximum likelihood estimation. Remember this, all these thing method can be applied spatial domain as well as the time domain. But very few book has mentioned that a maximum likelihood method in a time domain. And because of the maximum likelihood method in time domain, we develop a robot which can clean my floor, which can fly, and the higher version of robot is nothing but my drone. Okay, so maximum likelihood method we have adopted, we have developed the drone, we have surveyed many hilly area by using the drone. So the practical field experience we are giving here. So maximum likelihood estimation is a method by which we generally fit the parameter of a distribution. Why should we do that? Because we try to know that the laws that govern the data. For example, that the data from a wind measurement sensor, it follows that the variable probability distribution, many people say. But if you really nurture the data, you will say wind data never follows the variable distribution. Rather, it follows the exponentially weighted variable distribution. Many of the time, similar kind of thing, a sensor data gives a simple Gaussian distribution. But if you really look at the data, you will never find it out it is a Gaussian distribution. It is a Lorentzian distribution. Okay, because sudden approximation perturbation theory has incorporated there automatically because of the sensor signal processing. So then again, motion of a gas molecules follows the Maxwell-Boltzmann velocity distribution. So therefore, different physical phenomena, different physics, different laws is governing the system by a different distribution. So if I try to know the distribution, then definitely I have to nurture the maximum likelihood. And complete time domain, a simple distribution may not look like. And that is why spectroscopy method developed. And spectroscopy method developed long back, and there is a Wiener-Khinchin relations where we call that the power spectra autocorrelation is nothing but the Wiener-Khinchin relation. So where ergodic hypothesis we adopt to get this actual sampling domain. Now, how do I apply the maximum likelihood method? If I have to learn as a faculty development program, okay, I have a data, I wanted to find it out, maximum likelihood method, what kind of distribution it is, then definitely I have to do some procedure. So what is the procedure? If you look at a simple example I have some thumbnail experiment. There is a theta called probability of up, and there is a 1 minus theta probability down. If you look at the figure, it is very simple from the figure how to determine the theta. Theta is, of course, if you count, there are 8 ups and 2 down. So theta is automatically 8 by 2.8. So you will get the figure. It's a simple experiment. But this experiment, if I can map into the complicated one, in general, so I can say the theta as usual probability of up, 1 minus theta probability of down. So therefore, in the maximum likelihood, I have used the word likelihood. Likelihood from the principle of statistical mechanics is nothing but the similarly prepared system, or rather it's called the ensemble. So therefore, ensemble is nothing but the all are mutually exclusive. So it is a multiplication of all events. So what are the events? First event is theta. Second event is 1 minus theta. And if you continue that, I have this likelihood function. So therefore, the likelihood function is nothing but the multiplication of independent events. So therefore, this expression mathematically looks like theta to the power 8, 1 minus theta whole square. So therefore, if I have to do that, the maximum, I have to simply differentiate with respect to theta. So in mathematical terminology, we write into this form. So basically, you see here, I have differentiated the expression, and if I do that, make it equal 0, I have the various values of theta. I have to only pick up the in between 0 to 1, which is the maximum. That is 0.8, because therefore the maximum likelihood estimate is 0.8 for this type of problem. Same way, if you can generalize it, you will see that the theta is equal to n1 divided by n0 plus n1. What is n1? I have mentioned here. What is n0? I have mentioned here. So therefore, this is nothing but, and if you try to have the repeated experiment, then definitely I have to multiply it by that factorial, that n factorial divided by n1 factorial divided by n minus n0 factorial. So that is giving my the binomial distribution. So the basic origin of a particular distribution can come from the maximum likelihood with nurturing the data. Now you look at this figure. Here I am trying to, maximum likelihood method is also applicable for knowledge discovery, which is very, very important in case of the time series analysis, where knowledge discovery is always hidden and we try to recover that. We try to discover. I am taking a simply RC circuit as an electrical domain. So here I am trying to do that the RC circuit is discharging at the different time scale. So we are trying to know that probability of this IS circuit will discharge within a time between Ti and Ti plus dTi is governed by this exponential distribution. So we have to consider we have to construct a likelihood function. So therefore, likelihood function, as I mentioned, that it is a multiplication of all this. Pi is the symbol for product. So therefore, you take the log of likelihood, because when there is a complicated function, we take the log. So if we take a log, I will get this expression, and as usual, tau is my parameter. So if I differentiate with respect to this parameter, I will know that the tau is coming as this one. So that means about the tau, which I was not knowing at this stage, but if I root this process, I came to know that tau is nothing but my mean life. So therefore, in a situation, there are many such parameters. These parameters may be valued with certain time domain. And if I change the time domain, that may be again something. So therefore, time-wise, always discovery of the information is very, very important. Now, of course, mathematical people, to know further, if we try to develop the algorithm for a better way, we can go, for example, I mentioned that the variable distribution is modified into exponentially weighted variable distribution. Lorentz distribution will be modified by Lorentz and Cauchy-Lorentz distribution. So therefore, mixture distribution, when you have a combinatorics. So therefore, combinatorics also can be applied for a time series analysis. There are plenty. That is the research we try to do, that how algorithm can be developed. In this case, log likelihood function, you have to discuss the nature. From the nature only, you will get the algorithm. Okay. So this is again another problem. As I mentioned, that there is a binomial data. I have the likelihood function. You take the derivative, equate to 0, you will get the theta, number of heads and number of tail. So which coincides what could speed, and you can see that how that. So it is not an Gaussian distribution. It looks like a Gaussian. So many other time, Gaussian distribution is a cooked. Gaussian distribution is a cooked. That means for my consideration, for my simplicity of calculation, I maintain within a certain level of confidence is a normally distributed. Because if we are normal, we are okay. If we are not normal, I call it the abnormal, then we are not okay. So always we have to deal with the abnormal, and then only our challenge. So I call it as a normal distribution or abnormal distribution. All the abnormal distribution, Poisson distribution, variable distribution, then extreme value distribution, Gumbel distribution. There are many, Polyas distribution. So many distributions are there. So this is a maximum likelihood for exponential distribution. With this exponential distribution, with the time domain, with the spatial domain is given here, you can always mention that the x is the t and then t greater than 0, t less than 0, though t less than 0 may not be there. So always you go with this. But if try to do some kind of backward testing, in the case of the finite difference technique or finite element method, we have a backward method, so we can do that. And in case if you try to do the composite material, there is a technique called Hamiltonian mechanics or molecular dynamics simulation. There we always do the leapfrog method, and leapfrog method we apply for the backward timing also. That is for the computation load to be decreased. So if you do that, then always by usual procedure, you can get the parameter of the lambda by using that. And here you see that the lambda is nothing but the 1 by of this kind of mean. So reciprocal of the mean of the event is nothing but that lambda parameter. Similarly, if I try to do this some kind of numerical, I can go for the lambda ml is 3 by 13. Okay. So ml for uniform distribution, maximum likelihood. You can see that I can go for the uniform distribution. I can always try to take the log likelihood and make 0. You will get the what is my this parameter domain is the minimum, of course. And so though you are not knowing there is a minimum and maximum, but by likelihood you can always find it out what is actual. So you understand that what is A, what is B. It is nothing but the minimum and maximum. So now coming back to the ML for Gaussian, these are the Gaussian. So you see that if you go for the Gaussian, we have seen that this is a Gaussian expression. We are taking the log likelihood, and since there are the two parameters, I will have the two equations, and two equations I have to solve. Here the question is that if the Gaussian distribution is slightly modified, then you may have or if you have another parameter, you may have the 3 or 4. And these 3 or 4 equations, if you try to solve, you cannot solve by simple method. You have to apply a optimization rule. So optimization is one of the important domain, which is nothing but the Leeuwenberg-Markov algorithm can be adopted for doing that, or non-linear least square method. All these things one by one I will mention them. So now I'll try to show that some of the examples of the recent situation of the COVID-19 pandemic. You see that we wanted to know that the spread and the transmission of this pandemic situation. And here a lot of epidemiological model, which is a time dependent model, a bunch of differential equation, coupled differential equation. So we developed a code, and this code is already given to for many areas where prediction is almost working nicely. I will show some of the figure. So whatever the data is there, we try to develop the Italian epidemic curve with the 99.96 accuracy with this time series model. This model we develop from the data itself, and it will be surprising how we do that. So this is only the actual one has to learn how the model. This is a logistic model. By the use of the standard logistic model technique, like standard monod kinetic model, there are many chemical engineering solutions are there, so we can develop this. So with the help of that, we find it out, and therefore when we give it to the UK or the Italian country, they understood that yes, this is the right, and they adopted their lockdown measure as per that, and you know that the result today, they are free of COVID. So now, outcome of a developed logistic model and its comparison SIR model, the same model we predicted for our, it is a country for maybe the India. So you will see that at the May level, it is for the China. So we are having this prediction. And then we have this kind of thing, growth rate. It is for the same way we have this is the India situation, and you see that these are the data which I've captured from the May up to May, and it was showing the May. So therefore, it was going like this. So today, my prediction is up to November will be declining everything. So these are the things, my data-driven model in the time series, it is giving everything for our country. You can see that our final number of cases and epidemic size will be there. So our turning point and start of acceleration, everything 12 May. It was exactly at the turning point of 12 May for our country, and then ending phase will be 30th June. That was since that the data changes, now this was the changes. So therefore, the total epidemic will be 25th October, and as a safety factor, if we add that, it will go up to the second week of November. So these are the similarly observations. I need not to, these are the result of that my data analysis. And you see that such kind of sequence occurs. Now, if you look at, as I was mentioning, it is a time series data captured from 31st January to 5th July. Okay, now see up to this, I have some Gaussian. And from here, I have another Gaussian. From here, if I do, I have it. So it is a almost mixture of 3 Gaussian. So therefore, if I do the time demultiplexing technique, so we have a different types of time distribution which can be easily mapped. This is actually the mixture distribution. Same way, you see that the time series analysis, if I do that, I have. So therefore, this type of data, when you have to know that what kind of distribution in the time domain. If I simply take the Fourier transform, I will not get anything. You take the Fourier transform, this data I will give you will not get. So Fourier transform, we should not do much until and unless it is really required. We should go for the Gabor transformation. We could go for the wavelet transformation, because Professor Sina mentioned that the wavelet transformation where time and frequency both can be occurred, and many of the ECG, EEG, EMG signal always a wavelet signal. Speech therapy is a wavelet signal. So we can see that a time series analysis one has to do. So you have to open your eye and you have to not go for the as per the book, but sometimes you take the system from the book, but you apply your own knowledge also what should be done, as I mentioned that. So now second part is that we try to understand that whenever we have a time series data, whether they are fractal, because this is a new concept came very long back, it was there, but now we can very well apply. So now what is happening, so here we can see that that a fractal is a geometric shape. We need not to go to the fractal details because that will be again huge lecture. So we are trying to understand that the fractal applicable to the time series. If we do that, then we know that a fractal dimension is given by this formulation, where n is the number of circles, d is my diameter of the circle. So therefore, relation between the fractal dimension and the Hertz exponent is given by this one, and from there we can find out the beta. Beta is called as the Brown noise. So you have to understand that what is white noise, what is colored noise, what is brown noise. So there are different types of noise we try to do. The spectroscopy generally are interested. So our interest is that whether my time domain is a long memory or short-term memory. Okay, so you have to compute the Hertz exponent, and if you see that the Hertz exponent is always 0 to 1, the closer the value of the Hertz exponent to 0, the more the jagging of the jagging means that there's a lot of oscillation. Okay, and COVID-19 data we have modeled by fractal. This paper has been published into a very great journal with a high impact factor. And then the first time I showed that the COVID-19 data is a fractal, and a lot of things then requested to me to do that. Work is going on. So Hertz exponent is a measure of the smoothness of the fractal time series that is based on asymptotic behavior of the rescale range. So estimation is done by the R by scale, and then where t is the duration of the sample data, R by S is the corresponding. So rescale range is nothing but the measure the characterizing the divergence of the time series defined as the range of the mean centered values. So therefore, finally, once you do that, Hertz proposed that this R by S should be equal to K into 2 to the power H. And this particular thing can be adopted with the corrupted data also. So how much of corruption is there in the given data? You can easily find it out, and that you remove as a noise. By simply noise technique, you cannot remove that corruption. You cannot identify what is the corruption. But by using this technique, you can always find it out how much of corruption, so I can remove that. So that is the beauty of the fractal. So therefore, with the knowledge of that, I am not showing that any data, but tomorrow's data, I will show that the actual Hertz exponent, how to calculate, how that the LSTM can be feedback, and from there, how Kalman could get the concept. And though LSTM concept was not there, Kalman filter, particle filter, many of the combinatories can be developed that can be easily explained with no time. So Fundamentals of time series is they introduce the time series. There are some components and therefore some kind of deseasonalizing of a time series, because time series data is always affected for a season also if it is environmental related data like water quality, air quality, and so on. So fundamentally, that as I mentioned very previously, that I will explain only the definition, but actual work tomorrow I will show. I will explain some example also. So essentially, the time series is a sequence of numerical data obtained at regular time intervals. Professor Sinha mentioned this definition. It occurs in many areas like economics, finance, environment like atmosphere science, water quality, medicine, and also a COVID-19. You know that there is a drug delivery. If you try to do the drug discovery or drug delivery, you need to nurture the time series. Okay, today we are doing the vaccine so many trials, depending on the time situation that the vaccines reporting as a different. So it is a basically a time series. The aims of the time series analysis are to describe and summarize the time series data, fit a model, and make the forecast. So all of us, we are confining within that. We try to understand, we summarize, and then we try to fit a model and make forecast. This model can be a deterministic model, can be a non-deterministic model. Okay, deterministic model has got some limitation, but non-deterministic model may be having a wider applications. Okay, so why are the time series data different from the other data? It is because the data are not independent. Many of the time I have got the answer from many of the students from this Bengal when they came to the DBARC for interview. When he asked that this is the time series, okay, this is the time domain data, you tell me that you have distribution. They simply say that they normally distributed. Then I asked that they give the justification. No, no answer. Many people, many, and then they rejected. Because in our case of interview, we try to understand that we try to look at that the candidate should be very thorough in the fundamentals. That's all. Remaining things we will train him the way I have trained by my seniors. Same thing we train them. So here one should know that the time series data are not independent. They are always correlated data. Okay. So therefore, normal data may be independent, may be dependent, that is different. But in case of the time series data, data are not at all independent. Okay, much of the statistical theory relies on the data behind the independent and identically distributed. We call them. So therefore, if we try to do some kind of measurement technique for a time series data, we have to convert them as a IID. IID in the sense identically independently distributed. And that is a very challenging process. One has to do that. Large sample sizes are good, but long time series are not always the best. Series often changes the time, so bigger is not always the better. So the question now lies, when should time series analysis best be used? We do not assume the existence of deterministic model governing the behavior of the system under consideration. As I mentioned that, we never understand that a deterministic model can do something. So we not do that, but from the non-deterministic, there are procedures we can develop the deterministic model. So in instances where deterministic factors are not readily available and the accuracy of the estimate can be composed, so therefore we will only consider for the time being univariate time series. Though I started the multivariate, but to understand that we'll consider the univariate time series. That simply the time is the x-axis and y-axis is the response of the time, that is f of t. Some of the examples we can mention that the number of babies born in each hour, daily closing price of a stock, monthly trade balance of Japan for each year, and GDP of the country measured each year. Okay. Then there are the time series example. I need not explain. So you have the time domain, you have the year, and then the corresponding x value. Okay. So if you try to plot, many of the times you should plot the scatter plot, but you cannot join them. Okay, if you join, that means you have the data here also. Okay, so in case of the hourly data, we can do that. In case of the daily data, we should not do it. Some people they do, but that is a mistake. Same way that here you see that we did, but question is come, if I try to, this is the 1989 and 1990, so within that means it is an average data. I have done some kind of averaging, then only I am plotting a single point. But it is not. So you have to just give the scatter plot only, not join. So therefore, many of the time, either you draw the histogram or don't join this plot. So important of time series is understand the past, forecast the future. That is basically our. So we have to understand the past, and we have to understand we have to predict the future. So now what is the objective? Objective of the time series data analysis, any time series data can be decomposed into this component. Okay. So then you have to, I will explain all these components. So here we have to know that the interpretation, that is seasonal adjustment. We have to do the forecasting, that is predict unemployment, if either you call the unemployment or some other prediction. Then control, hypothesis testing, and simulation. So these are the basic objectives for a time series data analysis, which can be decomposed into many of the components. So now see what is forecasting, process of predicting a future event, underlying basis like production, inventory control, personal facilities. And many of the time it is surprising that the a time series data, even though it is exponentially weighted moving average model, but many of the time it is fitted with a peculiar distribution known as the Erlang distribution. Hardly you will find a paper with Erlang distribution, which is similarly Poisson-like, but not Poisson distribution, and not at all the exponential vector. Anyway, so that you will come to know. So we have a forecasting approaches, maybe qualitative, maybe quantitative methods. In the qualitative, you use when situation is vague and little data exists.
Hello.
Here only, yes, yes.
Yes, sir. Excuse me.
Uh,
Sir, we have written something in your private chats, and actually we have one session after this.
okay.
Sir, you will be with us again in the hands-on session. So
Okay.
if you, yes, sir.
Okay.
So as it is the inaugural session,
yeah,
so we have
yeah.
to.
So then I will just explain this slide and then I will stop. Okay.
Okay, sir.
Okay.
Thank you, sir.
Yeah, okay. So then we have the involve the intuition and experience, and we also have here we do the forecasting, sales on internet, and then in the quantitative method we have this kind of situation like used when situation is stable and historical data. We have the existing products and current technology. Then we have they involve some mathematical techniques. In the quantitative, we involve mathematical techniques. In the qualitative, we use the soft computing techniques, basically, I will mention. So that was our basic things. I have many things to say since Madhumita madam mentioned that some other session is there. So automatically we can go for that. Okay. Thank you, madam. And I will start the session from this slide itself onwards. Okay. Thank you, madam.
Okay, thank you, sir. If anyone has questions, so please we will discuss it in the afternoon or evening session, hands-on session. So thank you, sir. Thank you very much for elaborating your nice lecture about your experience, what we have learned, that how to model the data and how to test whether which model will be will be suitable for exploring exploring the data. So these kind of sessions are we really required, because we are several times in nature, in weather, in meteorology, we are getting this kind of variations, and maybe what you were telling, we have to test, or you have to test several features, that whether which model will be adopting for the data driven model. Thank you, sir.
Yeah.
Yes, sir.
Okay.
Thank you. Thank you once again. And
Yes.
participant,
Welcome.
please give the feedback. Hello. Prem, you have given the feedback. Hello.
Yes, ma'am. Yes, ma'am. It has been posted in the chat box.
Yes, participant, we have given the link of the feedback in the chat box. So please complete the feedback form and submit it. And the next session will be, we have a very confined schedule, and every sessions, and there are several FDPs are going on in Zoom platform. So we are trying to have the next session at 1:30, and it will be in the Google Meet. So you please join by 2. Okay, we'll be doing some kind of like experimentation, that whether Google Meet will be connecting everything, and after that you will be joining by 1:45 to 2, because our next session will be started from 2 p.m. on the Google Meet, and you will be all of you will be getting the link soon. Thank you once again,
Yeah.
everyone.
Okay. Welcome.
Okay, thank you.
Yeah, thank you to Professor Dotto for having a such nice and wonderful lecture to us, and we are very grateful to him for sharing his cutting edge knowledge in multivariate time series data analysis with us. So thank you, sir. Thank you very much.
So okay. So this session is now closed, right?
Okay,
Yes,
Okay.
sir.
sir, you will be joining with us, and you will be
Yeah.
getting a link from either Google Meet or maybe from the Zoom platform for
Okay.
joining at the late evening session.
Yeah.
That is
Sure.
an
Sure. Sure.
advanced
Yeah.
session.
Yeah.
Okay,
Yeah.
sir.
Sure. Sure. Okay.
And you will be joining even in the day session also, sir.
Okay. Okay. No problem. No problem.
Okay. Thank you, sir. Thank you, sir.
Okay. Okay. Okay.
Thank you, ma'am. Thank you,
Thank you.
participants, for participating this FTP program day 1, and the link will be provided for the second session, that is from 2 p.m. Thank
Right.
you all. Thank you, ma'am.
Now 1:30 will be trying in the Google Meet.
Yes, ma'am. All the
The
links will be
organizer
sent to
will
the
be there
Acha,
from
participants.
1:30. Okay, organizer will be there from 1:30, but participant will be from 1:45 to 2 p.m. They will be joining. Okay,
Yes, ma'am. All the
acha,
links will be sent to the
uh,
participants.
hello.
okay. Ah,
Madam, how can we distribute this brochure? I mean the
Prem, how can we distribute that brochure on every to every
Yeah, yeah,
participants?
yeah. I will give the database of all panel participants. That is by via mail.
Okay.
With attachment to the email, they
so
will send it.
shall I forward the brochure to you?
No, 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 no. You
Yes, sir.
don't
Yes, sir. You
forward
please
to.
just call me, sir. I will redirect you, sir.
Right,
Okay.
right, right.
So
Yes, sir.
Google
Thank you.
Meet
Thank
link,
you.
yeah, we will be forwarding to you. Google
Yes,
Meet
yes,
link.
yes.
Okay. Okay. Thank you. Shobit,
Thank
so
you.
please
Thank you,
do
ma'am.
accordingly so that
Yes, ma'am. Yes,
the
ma'am. Yes, ma'am.
participant can get. Thank you, Prem. Thank you.
Yes, ma'am. Yes, ma'am.
And
Thank you, ma'am.
Professor
Thank you,
Dashgupta.
Amitabh Sinha, sir.
Yes,
Thank you all.
Sinasan and Professor Dasgo, everyone you will be sending the Google Meet, especially Professor Dashgupta, because he has not able to join in the inaugural session, and we did also a mistake, because in inaugural session he has